So we are starting with the first chapter, that is functions and graphs. So the whole of the chapter is divided into modeling and equation solving, functions and their properties, 12 basic functions, building functions with from functions, parametric relation and their inverses, graphical transformations, and the modeling with functions. So we are on the first one actually, which is modeling and equation solving. So let's understand what actually functions and graphs are. So according to the example which is given in the book, they tell that one of the central principles of economics is that value of money is not constant, it is the function of money. So now let's understand it with the help of an example. Let's say in the year 2000, the price of my house was $10,000. Okay. Now, in the year 2005, the price changed to $20,000. Okay. Let's say, assume that in the year 2010, there was huge economic problems and there was some sort of great depression running the market because of which there was a recession. So in the year 2010, the price of my house didn't increase much, and because of problem in the market, the price of my house came down to $15,000. Now, fast forwarding to the current year, that is 2025, I'm going to sell my house. Everything is very much fine, and the economy is also pacing up. So the price of my house is 250K. Okay. So what do you learn actually from it? You learn that if you had taken it to be function, assume it to be y. Just let me find shade the tune stroke actually. So yeah, if you had taken this thing to be a function, say y, so y would be a function of time, f of t, y equals to f of t. Had I put the year 2000 in the time, which is the base year, so t equals to 0. If my base year is 2000, so t equals to 0. At t equals to 0, the value of y was 10,000. At t equals to 5, taking the base year as 2000. So in 2005, the price which my house was $20,000. So f of 5 would have been 20,000. And if I had put it to be t equals to 25, which is the current year, taking from the base year 2000, the price of my house would be this. So the y would have returned me actually this value. So this only they have tried to tell you that money is always a function of time. And similarly, the house which you are selling, it is exactly the value which you are gaining in terms of time, which we have already learned about earlier. So, talking about what exactly is a mathematical model. So, let me just tell you in short. A mathematical model is a structure, whether numeric, algebraic, or graphical. Numeric means you're telling in terms of numbers. Algebraic means you're telling in some form of functions. Actually, it is a function that is y equals to ax plus b. Just ignore my writing because I'm writing it with my mouse. And graphical, basically, when you tell in terms of a graph. So, this is all which a mathematical model tells you. And this helps us to approximate the real world phenomena for study or predictions. So, why is there a need of using different models? See, numerical models always analyze raw data. You need some form of numerical values in your data set. That is why you hold surveys to know that how much of the raw data you are having and then apply different formulas to it. Algebraic model is the next step. When you're having the raw data, what you do is that you plot it on the graph, which will be a graphical model, and you will find some sort of functions to predict for to make a model to predict the future values or to get the past values by relating those raw data, that is a numerical model. So when all three combines, you are getting a mathematical model. So let's now move to exactly what's given next in your book. They have talked about mathematical model, which I've already discussed with you, and numerical modeling is a modeling in which you deal with numbers to gain insights into the phenomena. So this is the thing. Like here, the example they have taken is that tracking the minimum wage. So what they have done is that they have taken the year into consideration, the minimum hourly wage MSW, and the purchasing power in 2020 dollars. Okay, so they have got this raw data set, which is called as a numerical model. Fine. Now moving on to the next thing. This tabular form was just numerical formation of the raw data. Moving on to algebraic model, which now adds to your numerical model. An algebraic model always use formulas to relate variable quantities associated with the phenomena which is actually being studied. So let's come here. If you are wanting to compare pizzas, a pizzeria always sells a rectangular pizza 18-inch by 24-inch pizza for the same price as its large round pizza, 24-inch in diameter. If both the pizzas are of same thickness, which option gives you the most price for money? This is always what you compare when you are going to some buying or a product or eating something. You always compare that from where I'm getting the most value for my money. And then you proceed for your calculations. So for the rectangular pizza, you know that it is length into breadth or length into width. So you're getting a 432 inches square pizza, and for circular, you're getting 452. So where you're having profit, you're having the profit of approximately 20.4 inches in circular pizza. So you'll move with circular pizza. And how you got to know this? You got to know this by the numerical model. See, this was the numerical model, and you have just combined it into algebraic form, which is the formulas to get your output. Now coming and moving forward, there is a graphical model. Graphical model is just what you saw in algebraic model and numerical model, but in form of graphs so that you can visualize things correctly. Because visualization helps us to understand more. Now, if you see this graph, what is the first thing? We have not read the example, what they're trying to tell. We can see the data and tell you that, okay, my graph is increasing from here to here, which means the graph is increasing. That means the things between which it is compared, like X and Y axis. So the value of Y is increasing whenever the value of X is increasing. So it is an increasing graph. Now, how it is increasing? Is it a constant increase? Because this is not a linear increase. This is an exponential increase because what we are getting is a parabolic function. So this increase is rapid. So this is what we know from graph by just seeing. We are not knowing what it is dealing with actually, but from seeing, we are understanding that it is dealing with something which is growing. So now come here and see. There we are having visualizing Galileo's gravity's experiment, where he spent good deal of time in rolling balls down the inclined planes, carefully recording the distance they traveled as a function of elapsed time. So what he was actually doing, he was calculating, he was recording the distance they had actually traveled as a function of elapsed time. So now he's relating with distance they have traveled with respect to time. Okay. So elapsed time at 0 second, it was distance is 0. At 3 second, it's 6.75. At 5 second, it's 18.75 units. And at 8 second, it's 48, which means that this ball is actually accelerating. It's accelerating. That is why the distance which it is covering is increasing exponentially. So how I can say this? I can say this by seeing the graph, because you are knowing there is an exponential increase, and you can see from the numerical model which is actually given to you that yes, there is an exponential increase. Now, in terms of algebraic model, how you can find this? See, at 1 second, it's 0.75. At the second, it is 3. At the third second, it's 6.75. So, what is actually happening is that they're having They're making an ordered pair at 0. They have just plotted the points here at 0, 1, 2, 3, 4 till 8. Now they're actually calculating what's the relation between x and y axis. And they get to know that this distance is equals to k times t square, where k is equals to 0.75. Now, you already know that we can calculate the slope of a graph using y equals to mx plus c equation. So here they have just denoted that if this was the time axis and if this was the distance, so as soon as at y we are taking the distance, at x we are taking the time. So if this was the whole thing there, let me just find my eraser so that I can rub this and make it more clear. And I have some shapes. Okay, here the time t is going, and here your distance is increasing in this graph. Okay, so you know these things which are actually given. So you see that at 0 second it's 0, at 1 second it's 0.75, at the second it's 3. So how much change is there? 0.75. If you open a calculator and just see 3 divided by 0.75 is actually 4. Fine. That is 2 times square. And if you just see the comparison of 6.75 divided by 0.75, it's actually 9. So you have got a relation that whenever you are increasing forward, what you are getting is k times t square. When t was 2, you are getting 0.75 into 2 squared is 4, which is equals to 3. Whenever you are moving to the time period equals to 3, what you are getting is 3 squared 9, which is equals to 6.75. So you were able to successfully find a relation that, okay, my algebraic model is this. You have plotted this to a graphical model. So this is the best example of a mathematical model where you are actually having a numerical model, an algebraic model, and a graphical model. So this is all what they're wanting to tell you in the starting that, okay, these are the things. Now, moving, we have covered the graphical examples. Now talking about the zero factor property, which is the next thing in your book. So moving on to the zero factor property, see what happens is that whenever you are solving an equation, an algebraic equation, many times it happens that while you are factorizing and you take the common x out, you just forget to equate it to zero, which is called as zero factor problem. Because there is a case, like if you see in the example here, they're telling you that 6x cube equals to 11x squared plus 10x. They have just taken it in normal regular form. And now they have told you that, okay, we are with this equation. Now what we have done is that we have taken x common. So we get 6x squared minus 11x minus 10, which is factorizable into 2x minus 5 and 3x plus 2. So we are having an x outside. Now just see what all I am marking. We're having an x outside to compare actually. And there is some issue again. Let me just sort it out. Okay, we cannot remove this like this. So what we will do is that we will remove it. Oh, it's gone. Um, Let me see how many times I need to do undo to get that page back. It's not coming. Oops. So we are gone with that. So we are not wasting time. I'll tell you the example right here. Yeah, we are having it here. So I'll tell you accordingly. Nobody can stop us from continuing. Not even the system. So we had this thing. We factorize it to get this equation. Now, three things we need to compare to x because this is just x is multiplied to 2x minus 5 and 3x plus 2. So we already know that if a into b into c is equivalent to 0, then it means that either a is 0 or Either B is 0 or my or doesn't seems like or still either C is 0. Okay. So these three things are possible. So that is why we equate them equal to 0. So x equals to 0 or 2x minus 5 equals to 0 or 3x plus 2 equals to 0. So we get these three answers. So this is actually the zero factor property where the product of real numbers is 0. If and only if at least one of the factors is 0. This I have just elaborated here. If and only if I double F stands for, let me just write it clearly for you so that you're not being confused. I have erased it and I'm writing it here. If stands for if and only if. Okay. So product of real numbers is 0 if and only if at least one of the factors is 0. So this, I have told you about this actual ABC. And this is true actually. If my A equals to 0, my B and C, no matter what they are, they would be equals to 0. If my B is equals to 0 and A and C are unequal to 0, then also my whole product will be equals to 0. So this is what zero factor problem is. Now coming on to the problem solving process which we have to deal with. This was a phase which was lost and they have given you this equation right here. So now, moving on to solving equation through comparing method. Okay. So x square equals to 10 minus 4x. We have taken it into normal form. That is x square plus 4x minus 10 equivalent to 0. Now we will be using the quadratic formula, which you already know about. Still, I will be telling you in short, x equals to minus b. First, we need to arrange the whole of the equation in this form, normal form, x square plus 4x minus 10 equals to 0. And then we need to start that x equals to minus b plus minus under root b square minus 4ac upon 2a. So if you put minus b comes minus 4 plus minus. Plus minus means two equation actually. See plus sign here, minus sign here. Plus minus under root of b squared, which is 16, minus 4ac, minus 4ac, which is plus 40 upon 2a, 2 into 1. So you get one answer as this, and another answer as this. So you can solve directly by the formula, the Sridharacharya formula, or the quadratic equation formula. Solving graphically, you can also solve a problem graphically by locating this x-intercept and y-intercept of graph, and then you will be able to answer what we have found here. So we use the graphing utility of the calculator to solve graphically in example 7. Most of the calculators have solved it, which will enable you to solve numerically, but I have just told you how we are actually solving it. So what are the fundamental connections dealing with? If a is the real number that solves the equation fx equals to 0, then these three statements are always true. The number a is a root or the solution. The number a is 0. The number a is x-intercept of the graph. So this is what which we will be coming while we will solving problems and dealing with. So let's leave it for then. Now coming on to George Polias, who is called as the father of modern problem solving, not only because he was good at it, but also because he published one of the famous analysis of problem solving, how to solve it. So, so the four problem solving steps are always first, understand the problem, what the problem is trying to tell you. Understanding is the basic, for which you need to read the problem, the question 2 to 3 times so that you are knowing, you are getting the crux out of it, that what you actually you're wanting to do. Then devise a plan. Devise a plan means run your brains that how you can actually solve the problem. Next is whatever method you have taken into consideration, just put them to application. Fourth is to look back because all the methods would not always make you reach to the destination. So look back that which of the problems have been actually solved, which means which of the plans was actually right. And this is how you do. So there in mathematical modeling, this is called as GAIMME guidelines. They're just the guidelines. Okay, let me just okay. So continuing. So they have just talked about the problem solving process, the grapher's failure. So we are coming on to the grapher's failure. What actually happens? The mistakes are that whenever you try to plot some graph, you have not taken into consideration some of the things which we'll be dealing when we'll be solving the questions. Not right now because this is not actually possible to understand just from this. So let's see what other things are left. Technological pitfalls, problem solvings, a word about proof. Okay, we have done with this. Now there is a question that prove n cube minus n is divisible by 6 for every positive integer n by factoring. So n cube by n, what you will be actually doing is that, let me tell you. uh, So if you just take into consideration the n cube minus n problem, what you can actually do is that, see, there is an n cube minus n. So you can write it in these terms, that is n common from both the things, n square minus 1. Okay. Now you know by the formula that a square minus b square is always equivalent to a minus b into a plus b. So from that, you can just separate it. My dot means it is in multiplication, although it is just referred, but I'm putting a dot for your understanding more that this is actually into n a square minus b square is a plus b and a plus b and a minus b. So n minus 1 into n plus 1. So these are the things. Okay, we have done these three things. So now can I write it more easily in this types for your understanding so that it's more clear, which is n minus 1 into n plus 1. Okay, so what you are actually seeing is that you are getting a number n, you are getting the previous number, and you're getting the next number, which means if I am taking into consideration my n equals to 2, what I am getting is that n minus 1 will be 1 into n, which is 2, into n plus 1, which is 3. I will be getting a 6, which is divisible by 6. If I take my n equals to 4, I'll be getting from this thing n minus 1, which is 3, into 4 into n plus 1, 5. So 3 into 4 into 5. And is this number divisible by 6? What is 3 into 5 into 4 is 20 and 20 into 3 is 60. So 60 is always divisible by 6. So you take any n in the world, for all n, this equation is correct that n cube minus n will always be divisible by 6. And how you have found it? You have just found it by opening the relation and factorizing it and simplifying it and running your brains that how can this thing be actually verified? And yes, this is verified. Even if you take n equals to 1000. So what you are actually getting is that n minus 1, 999 into 1000 into 1001. So we cannot multiply directly. So we'll be taking help of a calculator, which is 1001 into 1000 into 999. Is this number divisible by 6? If yes, if it is divisible by 6, my answer would be in integers because it won't remain, it won't leave any remainder behind. C, it is perfectly divisible by 6 because of which it is not leaving a remainder behind. And this is always verified because if I multiply by 6, I would be getting the same number again. So yes, these were the teachings which were from the first chapter, section 1.1. Now in the next video, we would be dealing with the questions which are in the chapter 1.1. Thank you. Hope you liked it.